This video we're going to take a look at the memory operator. Memory operator is found under Operators, Standard, Memory. And this allows us to store variables either on a per particle basis or on a global basis. This is kind of similar to data channels. We'll go here to the particle group. Data channels only allowed us to store certain types of data, and it only allowed us to store one value per variable. So memory is kind of an advancement over that. It allows us to store a whole bunch of different data types. And when we create one of these data types, we'll call it my position history. This is just setting the variable name. We have this option for depth, which allows us to determine how many variables each particle can store. And that's unique variables per particle. So a depth, it's zero based, so a depth of 0 means it can store one value. And if we crank this up to the maximum, which is currently 99, that means each particle can store 100 unique values in this. So go ahead and select here in the variable name, press enter, and that will set that variable on this memory operator. Now this variable is tied to this physical memory operator out here in the tree, in the scene. If we delete this, this variable is going to go away too. And on a big tree where you are accessing that variable in multiple locations, all those, you delete this memory operator, all those connections are going to disappear and nothing's going to work too well. So a really good habit to get into is to actually rename these operators something unique so that you know, hey, this is the operator that's got the variable on it. So don't delete it. Okay, let's just create a quick, easy example to show how this works and talk about how it stores and accesses values. So let's get a particle draw in here. Set our age rather high. Give us a particle. And go ahead and give that particle some velocity at birth. Remember, anything connected to a born particle output only gets evaluated at birth. So let's set this to 100 would be good, and we'll kick it off in the X and Y direction. So there's our particle, shoots up into space. We'll come down here into the next rule, and we'll have the all particle group. Now what we want to do is we want each and every all particle, and even though we only have one of them right now, we want each and every all particle to store its position information and remember it on a per particle basis so that each particle can remember its own positions. And what we have to do there is we have to connect the particle output to the memory particle input, and that tells it to operate on a per particle basis. So let's drag that variable down, put it in the inputs. That allows us to store values in there. And of course in TP4 we don't have to expose the position values in order to store a position anymore. We can just connect the particle to that position data type input. If we can, yeah, you see that position in parentheses. And it will automatically pull that position information out of the particle. And so let's go ahead and write to debug log, turn on debug, and take a look and see what happens. So here at frame 0, and we see memory key, which is the name of our operator. It's got a variable name, which is the name of our input, is storing a value, and it just, as we go forward and scrub and forward in time, it shows us all the values that it's storing. And what it's actually doing is it's actually, it's best to think of memory kind of as a stack, as a vertical stack. And what it's doing is it's pushing values down onto the stack one after the other and forces each one of them down further every time it stores a new one. If we want to kind of visualize this, we could think of a big box like this and have a whole bunch of vertical cells. And so up here at the top we have depth of 0. So it's basically meaning right near the surface. And down at the bottom, in our case, we have a depth of 99. So 100 total possible cells. What happens is on that first frame, on frame 0, is it stores, because we're not specifying a depth, it stores whatever value comes in directly into the 0 slot. And then when we go to frame 1, again, it's storing a value in, it just pushes it directly into 0. And it takes that value that used to be at 0 and pushes it down into 1. And so on, and so on, and so on. So every new value that comes in, it just pushes down on the stack. And let's take a look at what happens when we go to access that value. we'll take all particles and we're going to use a memory operator to access that output. We'll take that. There's our variable from this other operator. And this is the cool thing about memory, is that it allows you to access any other variable from all the memory operators in your entire tree. So we can access that variable from another operator and say, hey, output it. So it'll look and say, hey, does the all particle have one of those variables? And if it does, it's going to go ahead and spit it out for you. So we'll create a new memory operator, which is a really handy way to debug stuff. And we'll just create a new variable for position. Leave it at depth 0 since we don't need to worry about keeping track of history right now. We'll drag it to the inputs, and then what we're going to do is we're going to have this position value that we're accessing. We're just going to feed that into this other memory's position input so we can debug. And we'll connect the particle even though you don't really have to in this case. Well, let's not. Okay, so we'll go ahead and write to debug log. And what's going to happen is, let's reset this. Here at frame 0, this particular dynamic set, the all particle, it's storing its position. We do not specify a depth, so it just puts it in 0. And if we do not specify a depth when we access those variables, we're just going to get the 0 value, the 0 depth, back out. Okay, so it's just always going to read the exact same. All the way down, 9, 9, 12, 12, etc. So if we wanted to access a specific depth and say, hey, what was my position 10 frames ago? We'll set it to 10. We'll access depth of 10. And just to be good, we'll go ahead and connect this particle here in case we had multiple and we want each one of these particles to access his own depth of 10 ago. Remember, you have to have it on a per particle basis like that. So what's going to happen is we can start at 0, and it's going to go ahead and it's just going to read out the first value that comes in there. Then as we step forward, you'll see that this second one, this position input, is going to read the same value even though our memory key is changing until we get up to frame 10. Okay, 10 happens. Okay, now it's going to start to change, and it's going to be accessing, hey, what was our position 10 frames ago? So that's what that depth does for us. Now, just a point of interest, if you store values into a specific depth, let's say we want to store it into depth 5, if you specify the depth input, it's always going to force it and overwrite that value every time. It does not push down in the stack, so keep that in mind. We can show that when we step back here, both values are the same, that's expected. But here, as we start to go forward, it's showing us, hey, what value am I putting at depth of 5? That's what this value is here. Except this second position never changes. Even as we pass 5, 10, etc., it's always the same because this depth on input is always overriding the same cell. Okay, so this is pretty much the basics. There's one other way we could talk about how to use memory, and that is we'll set up a global here. We'll rename this, we'll call it memory global. And memory global, we'll go ahead and create a scalar here. We'll call it gravity value, or gravity. We only need to keep track of one value, so we'll just make a depth of 0. Drop that down here, and go ahead and create a memory float for memory, and say our gravity was going to be 720 in this case. Let's clear our debug log and look at it from the front view down here. Okay, we don't need to store position anymore. We don't need to read position anymore. What we're going to do is we are going to use our global memory value later on and tell these particles, oops, we're going to say, hey, access the global memory, get that gravity value, and use that when we apply a force to those particles. I need to set up 0.3 for the direction. Just make it negative. And so gravity here is going to be basically just going to read whatever that global variable is set to, and we can access that global variable anywhere else in our tree. So this is really kind of helpful if you have multiple dynamic sets where you want to change gravity values or force values over many different operators' dynamic sets without having to go through and update each one every time. You could just set the memory, a global value for whatever parameter. It doesn't have to be gravity. It could be any kind of thing like, boy, I can't even think of any right now, but I'm sure you could think of a dozen. So you can store your global memory values and then just access them later. That way you can always only have to have one connection to whatever your force value is and just pull off that global value. I guess I should try harder to think of more examples. But okay, so there's that. This is pretty much the basics of using memory. I think we mentioned it, but if we didn't, the important thing to remember is that data channels are cached. Memory values are not. So if you're going to cache a dynamic set and you want to be able to access whatever variables are in that dynamic set later, so if we cache this one and we're going to create some other one down below at the same level and try to access values that are stored in this cache dynamic set, you're going to want to use data channels because data channels are cached. So that's pretty important to remember. And of course you could always just do kind of a simple thing where you actually use your, let's create a data channel value. Let's call it my gravity in this case. Add that. You can always just access the memory value and store it directly into a data channel. And in this case, what happens is every all particle looks at the memory, says, hey, what's this variable that I've got? In this case, it's a global variable, but it could be on a per particle basis. And then you can just store that value directly into a data channel so that it gets cached. And that's really important if you're going to be doing things like Afterburner, Pyrocluster, or Krakatoa, anything that's going to rely on cached data channel values. Okay, so that's that. Let's move on.